My name is Bahar Sateli. I'm a manager in AI and analytics at PWC. I'm based out of Montreal. You might know that PWC is a global network of firms. So what I do is only kind of limited to the practice that I will talk about, what we do in Montreal, or basically in our Canadian office. But what I'm about to tell you is the fruit of about a year and a half effort of 7 PWC offices across the globe, from North America, from Europe, from Australia, from many offices that got together and thought about how we can do, how we can help our clients leverage AI in a responsible and ethical way, knowing that PWC is a large firm and has large clients. So whatever AI initiative they're gonna think of adopting, it's going to have really large consequences. So somebody has to sit down and think about what it would look like if we are going to, stumble upon a journey of a responsible AI. So being in the business and not being a tech firm, let's say, PWC has a lot of clients. They all heard about this hype of AI. They know that there is so much value to leverage when they adopt AI or AI initiatives or advanced analytics even, right? But when we come to the implications of what an AI might have on business operations or even the end users, the clients, really one word is, kept being tossed around in our conversations, and that word is trust. So what would it take for our clients who are looking to adopt AI to trust the system that they're developing, to trust to put it into operation, and to have trust when they offer it in large scale to their clients? That is the million-dollar question, really, right? So when we started thinking about how we can help the clients basically trust their AI, we started thinking into, okay, what is the reason that they might not want to trust it? So taking this really broad look at what the landscape of AI is, we've come pretty much a long way towards what AI is. We started from very narrow AI, mostly rule-based systems that had not much of a control, not much of power was kind of relinquished to them, to the area of big data, where they empowered a lot of more advanced analytics that we could do and a lot more advanced machine learning. We started daring to look at unstructured data, such as voice, such as text, such as handwriting, pictures, and other types of data. And now we are at a point in history where we really have to think about what we really want to do with AI. How do we democratize developing and use of AI? Because at some point we're going to move into the part where the distinction between human and AI and whether where does the human agency end and start is going to be very critical questions to answer. So we are at a point in time that we really have to set the right foundations. For us to have a good formatted and structured conversation, we need to understand what are the types of AIs that are really used in organizations, right? So if you think about along the two axes, one is how much of a control does a human have within an AI use case, as well as what is the purpose of that AI use case. We can land on one of these 4 quadrants at each time when we discuss. We can start from hardwired systems, which are designed to do a specific task, and there is a human in the loop to, let's say, to finalize the decisions or to use AI to make decisions. You're in the quadrant where you have assisted intelligence, right? So you are the human who's supposed to take an action or make a decision, and the AI is supposed to, let's say, pick up or look up a specific piece of data for you and bring it to you. You could have an AI system that is working with you, but kind of adapts itself based on the feedback or the interactions of that system has with you, and that will put you into more of an augmented intelligence. But if you're really looking at automating a lot of processes, you're looking into automation, and you will go into more towards automated intelligence, where these systems are still scripted. They are aimed at doing a specific task, but there is no human in the loop, right? So the AI is supposed to perform a certain task with some level of cognitive abilities for a person, and there's no human in the loop. If you go all the way and all the way to the bottom right of these quadrants, and you really become ambitious and you start thinking about driverless cars, then you're really talking about autonomous intelligence. The difference between is that there is usually no human in the loop to make the final decision or to do course correction, because you're really giving away the power to the AI to make decisions, but the AI can also adapt itself. A self-driving car is the best example here, because you take your hands off the steering wheel and you trust the driverless car to navigate through the streets. But there is possibly no way for us to be able to code all the possible situations where the AI is making a decision. So the AI is adapting itself in real time or near real time to make decisions on how to navigate in the streets. So when we have these kind of discussions with our clients, everybody wants to go for the driverless car. Not all the time it's an apt decision, right? So we usually talk about how much of a risk are you willing to, what is your appetite in terms of risk? How much of a power are you willing to give away to an AI? And do you anticipate to remove a person from a position and give the entire power to an AI? Or do you still want that kind of a dialogue and interactions to happen between the person and the AI? There's no one answer to this. And the reason for that is that AI is imperfect, right? People tend to trust systems until they crash or they make the wrong prediction. And sometimes those predictions have kind of irreversible or really, really massive impacts on the lives of people. So we thought the best way to go about this conversation with our clients is to think about the risks of AI, right? The risks of AI, given the non-deterministic nature of a lot of these models, is different from the conventional risk that organizations are used to, or maybe the risk associated with a typical conventional software. So we thought, okay, in a high level, we could categorize all these risks into six high-level categories. 3 of these categories that you see on top of the screen are business level risks. So these are the risks that will affect a certain business entity. And the 3 on the bottom are risks that involve all of us as a society, as a nation. These are the kind of discussions that we need not to have with each individual business, but maybe we need to have these conversations at a government level or the federal level. So for now, let's just focus on some of the risks that kind of affect the organizations hoping to adopt AI. On the one hand side, we always have the performance risks, right? There's always the risk of errors from an AI model making the wrong predictions, or having the model being biased towards a certain population in the data set. So you're thinking about, let's say, if the most famous or infamous example of the risk of bias was an AI model that was put to production in the judicial system in the United States. I think the project was called Project Compass. And they were using historical data sets to predict the risk of someone who was arrested to reoffend. And it turns out that after a while that this was put to production, someone started noticing, or a group of people started noticing, that this system is consistently giving higher risk scores to people of color, and specifically the African American population in their data set are always getting this high risk. So they started looking into those, and they had this famous case that you see on the right-hand side, that they had 2 different individuals. One was a white guy, and the other one was an African American woman. And the white guy actually received a really, really low risk. And these are the people who are kind of considered to be okay to go back to this society. But when they actually looked at their crime and their offense, they figured that the white guy was, I think, guilty of kidnapping or something like that. But the Brisha on the right-hand side, she had a petty crime. So I think she stole a bicycle or forgot to return a bicycle or something like that. But irrespective of that, they still got higher scores. It doesn't mean that the sponsor of Project Compass was a racist person or a sexist person. It just turns out the data set that they used for modeling was not a balanced data set. It had inherent bias encoded in it, and the model just happened to learn that. And in a lot of those cases, you can't tell that upfront, because more performant models are kind of opaque, so you can't really look inside their decision-making pathways and figure out, okay, so my model is consistently looking at the ethnicity of the person rather than the offense they committed. On the security side, these models are data-driven, right? So this approach is data-driven. So whatever data you feed the model has a very, very huge impact on its decisions or its output. So that also becomes their vulnerability, right? If you are smart enough to figure out or to reverse engineer or to guess how the model is thinking, and you feed it just enough noise in the data or just the right data distribution, you may be able to reverse engineer or to guess or to flip their decision by fooling the model. A very famous case in this case is when they were looking for image recognition for the driverless cars to understand the traffic signs, and somebody understood that if you have a stop sign, by just sticking a few white and black stickers on the sign itself, you can fool the model to think of it not as a stop sign but as a speed limit. Now take a second to think about it. If you have a fleet of driverless cars and they mistake a stop sign for actually a speed limit, not only they will not stop at an intersection, but they will also accelerate to 30 kilometers or miles or whatever the sign is telling them. And that has massive casualty, right? But apart from that, it's not just about the security, it's also cyber attacks, privacy risk of leaking data or inadvertently leaking something that shouldn't be leaked. And we also have the risk of controls. In a lot of cases, AI models are trained, they're tested, they're okay to go live, but they're embedded in a more complex system where there are not enough controls into what kind of data actually ends up being fed into the model. We have another infamous case of a bank I think it was in Australia, that had a very complex process where the AI was making decisions about whether someone is eligible for a loan or not. And somehow in the process where they were capturing some information from the end users to make a decision about them, there was a bug somewhere, they didn't capture enough or the right data, and the model consistently said, yes, you are eligible to take out a loan. So the bank ended up giving out loans, and people started defaulting on their loans, and that became a really, really big mess. And they had to shut it down. They had to kind of write off all those loans, and it had a really, really big financial impact on the bank. On the societal, economical, and ethics, I'm not going to really put a lot of emphasis on. We can have honestly half a day discussion in either one of these risk types, but we have things about like the Cambridge Analytica controversy and others, which really, really touches upon what are the societal risks of employing AI in every aspect of our lives. There's going to be an impact on the economy. We're going to have the risk of winner takes all. So whoever has access to the best data and the highest performing models will consistently beat others. And there is no need for me to really expand on the economical risk that it can bring. And at the end, and this is one thing that's very interesting personally also for me as well, is on the ethical risks. So for example, going back to the driverless cars, if the brakes go out and the car has to make a decision about hitting one person versus 3 people who are crossing at an intersection, which one should the car choose? Okay, so the assumption is that you have to hit something because the brakes are out. How do you code that? Do you ask the car to kill 1 person versus 3 persons because that's less casualty? But what happens is if that 1% is someone who's a CEO and the 3 other guys are like, I don't know, homeless people, you really don't want to go for less casualty. You want to go for least damage, right? And so how do you code that to a car? So obviously we can't. And MIT had this experience where they kind of started asking a lot of people, like kind of crowdsourcing the wisdom, saying like, what do you think should be the victim here? Who do you think the car should hit? And when they collected all those answers, they figured not only people cannot agree on one answer, but the answer shifts from one country to another, one culture to another. So these are the things you can't possibly code, but these are the things you need to talk about at every level, whether you're an organization or a government. So when we talked about these risks and we understood that, okay, so these are the typical risks, what can we do to manage these? So we got together as the firm, again, as I said, 7 different countries, different people, managers, consultants, partners, everybody. We got together and we really thought, what are the important pillars if we were to create one toolkit to manage these risks, not to remove them, but to flag and manage them. We ended up creating this toolkit that is composed of 5 pillars. Everything is dictated by a set of ethical principles. we came up not with our own ethical principles, but we did a massive market research on what other people think, big organizations, small startups, governments, national strategies, what do they think constitutes an ethical AI practice. We collected a lot of those principles. I think we studied about 60 different code of conducts. We ended up looking at roughly a dozen ethical principles where people think we should all abide by, and that includes being fair, being a beneficial AI. Does your AI make the world a better place, or is it just for efficiency of your processes? And once we set those ethical principles as our guideline, then you also need to kind of check in at every moment and make sure you're compliant. So underlining this toolkit is a governance map where we have all the controls and gates and everything that you have to pass through, guided and inspired by all these ethical principles to have an ethical and responsible AI practice. But at the end of the day, we're talking about models and data and source code and pickle files, right, in Python. So we understood that you also need a complement offering to these frameworks and laundry list of ethical principles. And that's why we came up with the 3 modules that you see in the middle. So everything that is tackling performance risk in terms of biasing data sets, biasing model predictions, fairness of the model decisions, and the second one, the interpretability, is can we actually understand how each decision is arrived or derived, right, by the AI's, the model's decision-making pathways. And the last one is that can we fool the model that's in production or it's being developed by a bank or an energy sector or any other person who has massive implications. And for all of these, for these risks, we took a subset of the risks that we can actually manage, and we literally created Python libraries that we can use to make sure that the AI that we develop is bias-free and is interoperable and cannot be fooled. And we also offer it to our clients which possibly procure the model or they're doing in-house development and they want help in case of addressing these risks. And looking at this toolkit as one big framework, one big toolkit that we can actually take out pieces and we can offer it to our clients, and anybody who's adopting AI will lead us towards a responsible path. I can talk about this responsible AI toolkit honestly for a day. We've only scratched the surface, but I kind of wanted to walk you through what was our thought process when we came up with this and why we think it's important for organizations or clients at whatever maturity level or at whatever size that they are to understand and adopt an ethical AI. Because let's face it, the banks of the future are going to use AI models to decide whether we or our children are worthy of a loan, of a mortgage, of a credit card. And we want to make sure that we set the right foundation now rather than later. There's so much thought leadership that we published around this toolkit. They're all available. I invite you to go and check out the PWC website on that and read all those. And I will share these links through Adam with you. And if you have any questions or you're interested in continuing this conversation, you can always reach out to me through LinkedIn. You can also have my email address, which is on the screen. And I hope to have this conversation with you soon.
In your opinion, Bahar, what are the privacy risks and benefits associated with facial recognition technology? I know it's really in the news at the moment. I think it was Michigan said no facial recognition technology. I know China is the most monitored country in the world, and they have it and use it and implement it to survey and control the population. What are your thoughts on that?
So this goes back exactly to the point that I have. There's a big difference in the culture of using AI. For example, in let's say in China, it's completely okay for people. It's accepted by people that they're under surveillance all the time, right? So now they've kind of accepted that they're under surveillance, and then at some point, these images, these video frames, and everything is going to be used for some kind of a massive AI system, right? So that will not only understand where they are at each moment in time, that it's in real time, that they can also extract your emotions. It's just, it's really, it blows my mind, right?
Mm-hmm.
And then you bring it all the way to the Western culture, and it's completely not okay to be under surveillance all the time. It's completely not okay to use my face for any kind of AI application. And because of this backlash, big companies such as I think Amazon and IBM, they just dropped their facial recognition practice because it's just not aligned with the ethical principles for the culture that they operated, but also the culture of their company. Mm-hmm. And what is the privacy concern is that you and I are giving away our privacy And it's not just the facial recognition, but for these a lot of these AI systems, you don't have a transparent view of where your data is going to, how it's being used, for what purpose it's being used. We have some mechanisms like GDPR in place, but
Not quite there yet.
yeah, not quite there yet. It's something to be adopted. I think it's been 2 years since it was introduced in Europe, but the lineage, everything around the data, and one more thing is that there's a lot of small companies, a lot of startups, a lot of boutique firms that are helping these bigger organizations or bigger clients to meet these AI initiatives, because organizations don't have an appetite or cannot afford 100 PhDs working in a distinct data science practice. So they give it away to these small boutique firms. While you can have an audit going over a big company, how are you trusting your data being copied over to some server of some boutique firm?
Yeah, no, so it's super interesting, and I love this space. I'm kind of like immersed in it, and I love hearing people like yourself talk and share your thoughts. So, thanks for answering my question. On to the next question. We have Akshay. Thanks for that. What are the usual steps taken in the industry to make sure data is diverse? What are the standard tests performed by deploying a DL model, e.g., a driverless car model?
We don't see a lot of driverless cars, the concept of autonomous intelligence in the industry yet. They're mostly, I would say, they're mostly in logistics, transportation, car sharing services, and others. There's also some AI that GM and BMW also introduced. We're not there yet in mass for the industry. We're not in the driverless cars. In terms of what are they doing to address these risks, such as diversity in the data sets, they're still catching up, and that's why we're thinking about bringing this toolkit, kind of raising awareness around this toolkit, as not as a sales pitch, but as something that we all need to be aware of. So now that they've heard about some of these cautionary tales and AI gone wrong and AI go rogue, they're looking into the data set, but I don't think they have that in-depth knowledge about. Let me give you an example. You want to look for a good balanced data set or fair data set. What they look at is, do they have a balance in terms of the instances? Do I have 50% male applicants? Do I have 50% female applicants? Great, I have a balanced data set. Let's train a model on this, right? That's not the case. This is some awareness of bias and fairness and diversity in data sets, but they don't have all the details of, if your model is making the right decision, it has to be a right decision for both populations. If it's also making the wrong decision, you have to make the wrong decision for both cases in the same proportion. Those are a lot of discussions that I have with our clients in terms of first just getting them to understand the risks before they kind of put that AI model into production, and that's going to make a decision about you and me in life.
Excellent. Yeah, thanks very much for that. A very, very detailed response. And the final question we have for you this evening, Bahar, is from Philip. And he said, have you ever been in the position where you had to make a tough choice between explainability and performance? Yeah, good question there, Philip.
Absolutely. And that's, hang on, that's a perfect question. There are two inherent trade-offs. One is in terms of explainability and performance. We all know that deep learning is cool. Deep learning, you don't even need to understand it. You just prepare the data, you feed it to the model. There is no feature engineering. You'll get perfect results, near perfect results, right? But those high-performing models are not explainable. There are some ad hoc approaches to make them a little bit more explainable, but not enough for a chief risk officer to say, I'm okay with this and this can go live, right? So sometimes we also have to have that discussion early on, even before they decide what kind of model they want to develop, to explain this. The second thing is also in terms of the accuracy and performance and fairness. We also had to have some tough discussions that, hey, if you want to create a fair model, this is the data set you have to pivot to, and these are the features you cannot use. Although if you had included them, you would get a better performance, but it might put your entire organization at a reputational risk. Somebody's going to call you out a sexist or racist organization tomorrow. How do you feel about that? And when they, where they take it back, we're like, okay, so these are some of the features you have to leave out. And that will hurt your accuracy by 5%, 7%, but at least you can sleep well at night.